NASA's Voyager spacecraft, which embarked on its journey nearly 50 years ago, continues to traverse unexplored regions of the universe, sending back startling information to Earth. Experts are both intrigued and concerned by the strange data emanating from Voyager 1, one of the farthest human-made objects in space. Launched in 1977, Voyager 1 and its twin Voyager 2 were part of a remarkable mission to explore the outer planets. Voyager 2 was the first to launch, departing from the Kennedy Space Center on August 21, 1977, while Voyager 1 followed about 2 weeks later. Both spacecraft weigh approximately 720 pounds, similar to a small car, and were designed to exploit a rare planetary alignment that allowed them to utilize gravitational slingshots to travel vast distances. On December 15, 1977, Voyager 1 successfully performed a flyby of Jupiter, marking the beginning of a series of significant discoveries. At a distance of 265 million kilometers from Earth, Voyager 1 sent back a remarkable series of images and data, including a spectacular 108-hour sequence that captured 3,750 photographs of Jupiter, enabling scientists to create a time-lapse film of the planet's rotation. In February 1979, the spacecraft explored the Jovian moon system, discovering new moons such as Phoebe and Matisse, and even detecting faint rings around Jupiter. Voyager 1 later made a similar journey to Saturn, where it observed several moons, including Mimas, Enceladus, Tethys, and Dione. After completing its planetary missions, NASA declared the end of the Voyager planetary mission and sent both spacecraft into interstellar space, traveling at a speed of 325 million miles per year. By January 1990, Voyager 1 had officially begun its interstellar mission, having transmitted some of the most iconic images and data of the solar system from a distance of 6 billion kilometers from the Sun. This included a famous photograph known as the pale blue dot, showing Earth as a tiny speck in the vastness of space. The spacecraft's cameras were later turned off to conserve power and memory, but Voyager 1 continued to send back valuable information from the interstellar medium. Alongside Voyager 1 and 2, NASA also operates the Pioneer 10 and 11 and New Horizons missions. Notably, Pioneer 10 became the first spacecraft to reach the outer solar system in 1983, eventually entering interstellar space on August 25, 2012. NASA confirmed this achievement in 2013. As of November 2018, both Voyager spacecraft officially left the solar system, with Voyager 1 now estimated to be about 14.5 billion miles from Earth. Despite its incredible journey, recent reports indicate that scientists have observed unusual anomalies in Voyager 1's data transmission. The spacecraft appears to be sending strange signals, creating a sense of uncertainty about its condition. While Voyager is still functioning, receiving commands from Earth and transmitting data, NASA has detected inconsistencies in its readouts, raising questions about its internal systems. Each Voyager spacecraft carries a unique 12-inch gold-plated disc containing sounds and images from Earth, intended as a message for any extraterrestrial life that might encounter the spacecraft. This disc includes 35 musical tracks, 115 images, and greetings from prominent figures like former U.S. President Jimmy Carter and former UN Secretary-General Kurt Waldheim. As scientists continue to analyze the data and monitor the health of the Voyager spacecraft, they remain hopeful that these remarkable missions will yield further insights into the mysteries of the universe. The Voyager spacecraft, specifically Voyager 1, has been the subject of numerous discussions regarding its ongoing mission and the challenges it faces. Currently situated in a distance of about 14.5 billion miles from Earth, the spacecraft is experiencing anomalies that some researchers have speculated could be due to extraterrestrial influences. However, such claims have been swiftly dismissed by scientists. The mission's success hinges on its communication systems, which depend heavily on the spacecraft's antenna and control systems. Voyager 1 continuously focuses its receiving antenna on Earth, allowing scientists to collect data effectively. This system also plays a crucial role in determining the spacecraft's orientation. Engineers monitoring the situation have confirmed that the probe is functioning as expected, despite the mysteries it presents. Notably, none of the safety features designed to protect the spacecraft from potential hazards have been activated, according to Susan, the DoD project manager for Voyager 1. At over 45 years old, Voyager 1 is significantly older than originally anticipated in the mission plan. This age presents standard technical difficulties for the engineering team working to troubleshoot the spacecraft. The immense distance separating us from Voyager 1 complicates matters considerably. Communication signals take nearly 21 hours to reach the spacecraft, meaning that any instructions sent by the engineering team require a total of 42 hours to be processed. Consequently, two-way communication between Earth and the spacecraft averages around 2 days. This delay poses a substantial challenge for immediate troubleshooting and requires careful planning for each command sent. Unlike missions conducted on Earth, where engineers can quickly send and receive instructions, the long communication lag demands a more strategic and efficient approach. Each command must be meticulously planned to address perceived issues without introducing new problems, as it takes time to verify whether the command had the desired effect. Furthermore, the extensive communication delay limits the engineer's ability to interact with the spacecraft, necessitating that every command is precise and leaves no room for error. This requires extensive attention to detail and careful validation of orders on Earth before they are transmitted to Voyager 1. Additionally, the spacecraft itself is over 40 years old, having launched in 1977, and operates on systems and designs created during the 1970s. This retrofitting adds another layer of complexity to the troubleshooting process. Voyager 1 has also faced harsh environmental conditions in space, including high radiation, extreme temperatures, and micrometeoroids, which have contributed to the wear and tear of its components, making maintenance and repairs increasingly challenging. Despite these obstacles, the engineering team is committed to resolving the current issues. They are exploring various theories about the causes of the anomalies and simulating potential responses on Earth. This deliberate and methodical approach is crucial given the stakes involved. Any erroneous command could jeopardize the spacecraft's functionality or result in a loss of communication. The engineering team is also leveraging the redundancy built into Voyager 1's design. Like many space missions, Voyager 1 was constructed with backup systems to enhance its resilience against failures. If a critical component begins to fail, the engineering team can switch to these backup systems to restore normal operations. In summary, while the challenges of diagnosing and resolving issues with Voyager 1 are substantial, the engineering team is drawing on their extensive experience and the spacecraft's inherent adaptability to navigate these complexities. Their careful and patient approach is essential for managing the long communication delays and the challenges of working with a spacecraft that is both extremely distant and significantly older than anticipated. Despite the many difficulties, Voyager 1 continues to uphold its legacy of exploration and scientific discovery well beyond its original mission parameters. The anomalies it faces may be linked to cosmic rays impacting the spacecraft's sensitive electronic systems. These high-energy particles, originating from distant supernovae or other cosmic events, travel through space at nearly the speed of light. When they strike the spacecraft, they can penetrate its exterior and disrupt internal electronics. The longer Voyager 1 remains in space, the higher the likelihood that cosmic rays will affect its systems over time. Experts have long recognized the risks posed by cosmic rays to both spacecraft electronics and human explorers. However, predicting their impact and mitigating their effects can be challenging. Despite these potential dangers, engineers have implemented various strategies to protect the spacecraft from cosmic rays, including protective shielding, redundant systems, and error-correcting codes for data transmission. Nevertheless, cosmic rays can still pose a threat, particularly for spacecraft operating in deep space for extended periods. As for Voyager 1, while the recent data irregularities are not entirely unexpected, they remain puzzling given the spacecraft's age and prolonged exposure to cosmic rays. Researchers and scientists are eager to monitor the situation and analyze the incoming data to identify the root cause of the anomalies and develop strategies to mitigate their effects on the spacecraft's operations. In spite of these demanding conditions, Voyager 1 has far exceeded its original mission expectations and continues to provide invaluable insights into the outer reaches of our solar system and beyond. Its accomplishments stand as a testament to humanity's enduring curiosity and determination to explore the uncharted territories of space. Looking ahead, Missions like Voyager 1 will inspire and expand our understanding of the universe.